Okay, a little bit of recap first. VSEPR theory, we normally use it to predict three-dimensional shape of compounds as long as we know the two-dimensional shape of it. This time, let's look at our good old H2O. It looks like it's linear, but in fact it's not. Step 1. Construct a Lewis dot diagram of water. Boom. Double check using the octet rule. Then identify the central atom, lone pairs around it, and any other attached neighboring atoms. Once that's done, step 2. Convert into a structural diagram. At this point, you notice that the top valence electrons, they are too close to the neighboring atoms. Same goes to the bottom lone pairs too, if you think about it. So even though the structure in two-dimensional situation looked like linear, those can never be linear. If you distance them far enough to each other, this is the ideal shape you will get. We call it bent or V-shaped. Notice that the two valence electrons are out of the page and the other two into the page. Now, step 3. We can determine the VSEPR shape using A, X, and E, and using those symbols to represent. As a result, you will get AX2E2, known as bent or V-shaped. Now, let's look at the simulator. Let's start with the linear. You'll notice that those repel each other complete opposite. Now, as soon as I add one lone pair, it's 120 degree. Now, if I add one more, the angle becomes 110, and you notice that two valence electrons stick in and out of the page and make others V. Let's do a quick recap using the other two examples. Step number 1, Lewis dot diagram. Don't forget about the octet rule as a guideline. Step number 2, convert into structural diagram and focus on A, X, and E. Step number 3, determine the VSEPR shape using A, X, and E. Then the three-dimensional shape. If you know, you know.